Hi, everyone. My name is Robert. I'm from the Westerdijk Institute in the Netherlands. I'm the head of the bioinformatics group there, and I used to be the curator of the yeast collection. So I'm not a specialist of bacteria, but I was asked to give the point of view, or at least some of the experiences of the fungal people. So I'm going to talk to you a little bit about the tools that we have created to register new species of fungi, which is called Mycobank. And then I'm going to talk about a few issues and problems in terms of the number of species described versus the estimations. And then why do we need species, if we need species, or if we need to work with strains or other kinds of units like sequences or genomes. And then finally, we'll reach a possible conclusion. So first, a few words about Mycobank. So in 2004, when I was discussing with Pedro Cruz, the director of the institute, of the Westerdijk Institute at that time called CBS, we were complaining, both of us, about all those pieces that were described in many, many different types of journals around the world and that were not always accessible, available, and for which we had no information about where they were and so on. So to give you an idea about the problem, in 2020 only 800 different journals were used to describe species, journals or monographs or things like that to describe new species. So how to be aware of all those descriptions, that was not possible. Therefore, we created Mycobank, and we were reaching the journals to try to ask them to enforce to get a Mycobank number to be able to describe a species. And so we created a tool which we called Mycobank, where people would be able to deposit their descriptions, their type strains informations, and so on. And eventually, this became a mandatory process. So the process is the following. So researchers are depositing their data into Mycobank using an online form, and they are getting a unique Mycobank number for those deposits, for each of the deposit they do. And then they submit those Mycobank numbers and their data and papers, of course, to the journals they want, which is asking reviewers to review the paper. When the paper is accepted, therefore the species is accepted as well. And then the release is done through a Mycobank process. So that's the way it goes, which is fine. The advantage of that is that all fungal descriptions are in a central place. It gives a lot of awareness about the new species that are described and the species that belong to a genus, that belong to a family, and so on and so on. There is more standardizations, therefore less chaos, and the data are findable, accessible, interoperable, and reusable, which is a very big thing at this stage right now in the modern science. So it looks like this. The website is at this address, and when you want to search for a given species, you just click on a given web page like here, and you are able to search for a given species, for example, like that, and you can see the detail of that particular species with all the synonyms and so on, the morphology and the descriptions and all the different types of things that are available for that particular uh, species. So that's quite convenient and interesting for not only the taxonomist, but also for the end users to kind of know what are the properties of those different types of things. Then you can also register the new species into the system through a form like system. Well, here you need to be registered. I'm registered here, but there you just type the genus name, the epithet, and the different types of features that are in most of the cases mandatory. Some of them are not mandatory, but at the beginning here, all the things here at the top are mandatory. Some of the things are also mandatory, like the typification thing, which is in line with the problematic of today. And here you can see that you can deposit different types of type material, epitype, holotype, of course. Um, we can even deposit iconotype in meaning pictures in mycology. I would not say that to me it has the same level of information than DNA and all the type of information we can get from a complete study. But anyway, in some cases, that's maybe the only thing we can get from the researchers. We have also already included the ability to put nucleic acid types, which is not yet officially recognized, but we are getting ready for the moment where it will be recognized if it is becoming accepted by the code, which is not the case yet. So there are plenty of discussion around that. And here you can also deposit DNA sequences. You can put the NCBI identifier or the sequence directly, and so on, region by region. At this stage, we cannot yet put genomes because sequencing a fungal genome is much more complicated than sequencing a bacterial genome. So we are not at that level yet, but I'm sure that over time and when the technology will improve, that will become something more important and possible in the future as well. So okay, we have now a place where we can store all those species, but how many species do we have? So you can see here the evolution of the number of species descriptions over time. So the first species we have was described in 1689, and there was a peak in 1898, for example, here. I don't know who described plenty of species there, but doesn't matter. That's not the point. And here, nowadays, we are about 300,000 species described, 393,000 species described, with a rate of about 4,500 species per year that are being described. That's quite a number, but this is far from sufficient if we look at the estimated diversity that is out there. And of course, those papers here are estimations, and so we are not sure that the numbers that are proposed in those papers are real, are close to the reality, or are very far. But roughly the estimations are going from 1.5 million species of fungi up to 10 million. So, well, that's difficult to say, and it's very much speculative, but that's interesting. And so at this stage, 150,000 of those 400,000 legitimate species are recognized as current species, are real species, if you want. So out of the 4 million estimated, it means that we only know about 3.75%. Well, that can be 3, or that can be 1%, or that can be 0.5, or that could be 5%. We don't know exactly, of course. But if we agree with those numbers, and if we look at the rate of species description at this stage, it would take 855 years to describe all the diversity that is out there. And as we know that the biodiversity is disappearing very quickly, that's a huge problem. So can we continue at this pace? I'm not sure. Can we increase this pace? I'm not sure. And so we probably need to find other ways of doing systematic work. So why do we describe species in the first place? And I was in the workshop last week, and Ian was saying, well, we want to to put species on the map. And so I like the analogy, and I found that it was quite a nice analogy. And I took this analogy to describe something a bit special in my eyes. So if we agree that this is a species on a map, well, I take here the geographic analogy, if you want. Um, this is a species, let's say. Okay, now, that species can be described based on the morphology only, or on morphology plus physiology here, or on morphology plus physiology plus DNA barcode. And then if you add the genome, well, that's even more precise and with more information and so on, of course. So at some point, when you zoom in to a very low zooming factor, or not zooming so much if you want, then the dots are all the same. You can distinguish the things from one another quite easily if you are not looking into the details very much. You know, a microbe is a microbe if you want. But if you zoom in a little bit more, you will see that just morphology is not going to give you a lot of precision, and it will not be a dot on the map, but an area. And in this case, it's not very precise, while this one remains quite precise and having the same kind of level of precision. And the more you zoom and the more you want precision, the more you want to have information related to the beast you have in hands, the less characters you have to describe the species, uh, the less accurate the information you will be able to reach from this from the species description will be available. So, and as you zoom in even more and more, you can see that, of course, at some point, morphology only is not telling you much. Even physiology is not telling you much, and DNA barcode neither. So while genomes plus other types of information like physiology, morphology, ecology, environmental information, and plenty of others will give you a very precise information about the abilities of that particular thing. And that thing may be a species, okay, but that can be a strain, even better, because one strain could be there and another one could be somewhere else, just close to it, but maybe not so close as we are going to see now. And so, if you want to do diagnostic and species delimitations, they are very much dependent on the tools, the data, and they are very much time dependent. When a taxonomist is able to define uh, the differences between two species at some point, this person is doing it knowing what he knows, meaning that having the data that he has and comparing with the surrounding species that are known at that moment in time. But as you know, the number of species is increasing very much over time, and therefore the boundaries of those species are changing. And here, this is what we see here. For example, you see that at the beginning, you have only a few types, a few strains, a few individuals that are very much separated from one another, and therefore you can easily say that this is species 1, species 2, species 3, and so on. That's easy. When you introduce more strains, it's becoming like this, and then like that, and then finally it's becoming more and more complicated and becoming a nightmare. And the work of the taxonomist, together with all the people that need to validate the difference between the things, is becoming, you know, very complicated. And therefore, we absolutely need to work in a different way, I believe. So, precision of information is very much important. And in the fungal kingdom, we have decided to use the ITS as the barcode, and the ITS region is around 600 base pair, maybe a bit less, maybe a bit more, depending on the species and the quality and so on. But that's still only 600 base pair out of 12 million base pair if we take a yeast genome, for example. So it's one page out of 20,000 pages. So the information we retrieve from that particular strain for a given strain, is very little compared to all the things that that particular beast can do. So I would say that a single barcode would not be a good idea as a reference system for an alternative code of nomenclature and things like that, which is not what you want to do, I know. But in the fungal kingdom, there are discussions about using one or two or three DNA regions to anchor candidate species, so kind of candidatus species that you have, for example. But what about the rest? So here we have an area and not a dot. When you use such a little amount of information. If you would use a genome, of course, that would be a bit different. For example, here we are using 530 orthologous protein coding genes to produce this tree. This tree was made quite a long time ago. And here you see all some of the species of the genus Saccharomyces. And here you see the picture of the type strains of both of them. And again, this tree is based on, quite a large number of information. But you can see that this is the same genus, and the distance between the two most distant species within this genus is about the same than between this one and this one. Okay, here it's a little bit more, I agree with you, but you can distinguish those two, but here you cannot distinguish them at all. They are very close to one another, but behind there are plenty of differences, and this is the surface problem versus the dot that we were just talking about before. Here is another example, probably much better, where they did a comparison between the distance within genomes of yeast and the ones of more common things that normal people would know better, like Homo sapiens and Mus musculus, for example. Here, that's about the same distance. So, would you say that those two things are belonging to the same genus? No. While here, yes, those things even much further are belonging to the same genus. So, a species here is not a species there. That we all know. But remember, we are not talking here just for self. We are producing tools for the community. And when the community sees that, and they are not specialists of taxonomy and nomenclature and all those kind of things, and when they see that two things like this belong to the same genus, they think, oh, then it's very close, like it's like Homo sapiens, Homo erectus, or whatever. No, it's very distant. There's plenty of differences. Another problem is that, at least in the fungal domain, is that we do not have much sequences. Most of the sequences available from NCBI, this graphic is from the NCBI data, obtained from NCBI, obtained in 2 years ago in 2018. But it gives you an idea about the distribution of sequences. So most of the sequences are from a certain group, and for most of the most of the fungal groups, we have nothing or almost nothing. So we are still very far away from having complete descriptions, and even barcodes are not available for many of them. So shall we work at the species level, strain level, specimen level, samples level, sequence level, genome level, or even time? That's also playing a role. So if you have a bag of soil or a sample of blood or something like that, for example, you may have a lot of different strains in this bag of soil, for example, and what you want to do is to classify them or to sort them out in species groups, in drawers, and put all those strains in boxes like that, hoping that those boxes will reflect their properties. And sometimes it's the case, sometimes all the strains of a given species have the same properties, while in other cases it's not the case. But here is the case, but different species share the same property, which can happen, of course. But if you would do a grouping based of the strains, based on a certain feature, for example, the ability to digest glucose or the ability to produce something or to be resistant to an antibiotic or something like that, you would have that kind of grouping. Here you can see that the grouping at the species level is working pretty well, and that the feature is species specific, I would say. But if you have things like this for another type of feature, then you're not sure anymore that the species is very valuable. Uh, at this stage, you probably prefer to have the information at the strain level. And when you have things like this is even worse because, the species are not really consistent in terms of that feature. And so you have a problem there. So what should we do? Those two guys are both Homo sapiens, but they are not the same, obviously, and they are not doing the same thing. They are not able to do all the same things. Plenty of their features are the same. But if I want to build a basketball team, you guess which one I will choose, So it's not the same, even though they are both members of the same species. And then even if you have an individual, an individual in a certain circumstance or in over time or depending on the environment will have different properties. This guy here is not the same than this guy here. His physiology is quite different, although it's the same individual in this case, but over time it has evolved, it has changed, and therefore the properties are different. And this is a good example here. Here, this is the world record owner of the 100 meter, Usain Bolt. So is the 100 record holder, but this one too. But this one is 100 years old. This one is doing it in 42 seconds, while this one is doing it in less than 10 seconds. So is it the same? No, it's not the same. So there's plenty of parameters that we need to take into account, and the species information is not giving us all this information. It is even sometimes blurring the information and giving us some false information. So what I would suggest is to try to gather all the information we can and possibly can, and the more the better, at the strain level, at the individual level, or the unit level. So sometimes the unit level is a species, okay, but in some other cases it will be a strain, in some other cases it will be just a single specimen at the moment in time, or it would be possibly a sample too, could be a sample of soil and things like that. So different levels of information. And from there, draw conclusions that are quite dependent and will use different types of information or pieces of information according to the needs of the fields that is in question. So the idea would be to retrieve all the possible information, and we know that in some cases we will have a little bit more or a little bit less information depending on the unit, you see. But the more information we can grab, the more deductions we will be able to do, and the more correlations we will also be able to do. If we have a lot of information at the unit level, we are able to do more correlations that are valid. While if we work at the species level or genus level, even worse, or even worse, at the family level and so on, the higher the ranking level is, the less accurate the information will be, and the more fuzzy the information will be, and the less we are going to be able to use this information for real scientific investigations. So with so many data, we are able to draw conclusions, and I would just argue that recording things at the unit level is the best possible thing to do. And using strains that are in collections is a gold mine because you can come back to the strain, reassess a certain property, check this property, do some experiments, and enrich the information at the strain level. And this is an extremely valuable thing that we can do with strains. However, I can understand that with genomes, that's not exactly the same. You don't have the same possibilities, but you have other types of possibilities. And if you cannot cultivate the strains, this is certainly a very good idea to use genomes as an anchoring system as well. So the conclusions are that we should probably move. Well, we were working with binomial nomenclature for many years. We starting with this guy Linnaeus, um, and then at that time the idea was to use boxes, drawer-like categories, and species-centric systems, um, which was for that moment in time a very good system, a very good system. For sure, I'm not criticizing this, and I still this has some values now, a lot of values, but you can understand that now with the rise of the computers, the software, the algorithms, the artificial intelligence, the automation, the next generation sequencing, and plenty of other ways to characterize units, whatever the unit is, uh, uh, we are going to a paradigm shift for sure. And so you can see that with modern system, data can be used in plenty of different ways to infer um, hypothesis. I mean, to test hypothesis and to draw conclusions. And we can work with an n-dimensional system, while the drawers are probably, more or less unidimensional or two-dimensional, or in the best case scenarios, 2 or 3 dimensions, but not more. So this is a completely different way of working. And so what I'm saying is that it's not that we should abandon the binomial nomenclature and the old system, but for sure, inevitably, it will disappear in favor of the new one. I don't know when it will be completely obsolete, but it will come for sure. So we certainly need to invest a lot in automation, in computational power, in databasing, in algorithms to cluster, to analyze all those data, in artificial intelligence, in software optimization. And when I say automation, that's not only related to computers and things like that. That's also automating the retrieval of samples, the analysis of samples, and all those things to make it faster, more accurate, less subjective, and so on. Those things are really important. Another key thing is to reward good databasing and equally, and to give it an equal value than conventional publication, or equal, or maybe slightly different, but that's really important to push people to put their data in databases and to record quality information in quality databases. The problem will be the willingness and the time to do it. But if there is an incentive or an obligation to do those things, then things will become quite good. So let's work and think out of the box, and probably out of the binomial box only. Thank you very much.